This is Foundations of Math and Pre-Calculus 10, Chapter 6.2. We're going to be looking at linear relations. Now, linear relations are relatively easy to analyze, but in the next 2 years, you will learn to analyze many nonlinear relations. And many concepts from linear relations transfer over to nonlinear, so it's a good idea to get a good grasp of these concepts. Okay, let's try to recognize linear and nonlinear. And this one is linear. And why is it called linear? Because it has the word line in it. So if it forms a line, it's linear. This is a curve, so it's nonlinear. And in case you're wondering, this is called a quadratic. It has degree 2. And again, this one has curves, so this is nonlinear. Again, if you're interested in what kind of function this is called a quartic function. And this one forms a line, so it is also linear. Now, regardless of the variable name, the horizontal is the independent variable, and the vertical is the dependent variable. And usually we write the relation explicitly for the dependent variable. So y is the dependent variable. It depends on what x is. And because we have y equal, it's called explicit. So y equals negative 2/3 x plus 1. V equals negative, in brackets, x plus 1, all squared, plus 3. And this happens to be this function here. And here we have k equals, k is the dependent variable, j is the independent variable. So k equals negative j plus 5 times j plus 2 times j minus 3 times j minus 7. And that is this quartic function. And for the last graph, we have s equals t. S is the dependent variable, t is the independent variable. What is the opposite of an explicit function? Well, it's an implicit function or equation. And here we have 2x plus 3y equals 7. So you can see that it's not like this one. Now, do the linear ones, this and this, look easier than these ones? Yes, it should look easier. Okay, so here's an example of looking for dependent and independent variables. The car travels along the highway. The variables are time and distance. Okay, time is independent and distance is the dependent, regardless of the variable that we use. 2. An experiment measures the growth of 10 bean plants. The variables are height and the plant number. So the plant number is the independent variable, and the height is the dependent variable. The height depends on what plant it is. The plant does not depend on the height. That doesn't quite make sense. Teacher records grades for a test. The variables are grade and student number. The student number is the independent variable. The grade depends on the student. The last one, a statistician is recording shots in a hockey game. The variables are the shot number and the position. So the shot number is the independent variable, and the position is the dependent variable. So one way to test if something's an independent variable or not is to see if we have more than one occurrence. So if we're looking at the shot number can only have one position, but a position could occur at different shot numbers, so position would not be the independent variable. Okay, the next concept is continuity. So if the relation is made up of points, it is discrete. If the relation is made up of curves, and a curve could be a line, it's a special case, it is called continuous. Okay, so let's try to classify these. This is a curve, so it's continuous. These are all points, so it's discrete. These are all points. It is also discrete. And this is a curve, and this is a curve, so it's continuous. Even though there's a break, we call it continuous. Okay, algebraically, we can show if something is a linear relation. If we have an equation, there will be one or two variables, and each term will be degree 0 or 1. The degree is the sum of the exponents for the variables in the term. Okay, so we need to determine if these are linear or not. Here, everything has power 1 because it's implied, so this is linear. Here, we have x squared. The power is not 1, so the degree is 2. This is nonlinear. And you don't need to know this, but it's a quadratic, just in case you want to know what it is. Here, degree 1, 1, so this is linear. Okay, this is a little bit tricky. This is degree 1, this is degree 1, but we have to look at the term, the whole term. So we add up the exponents here. This is actually degree 2. This is nonlinear. Another algebraic way is to determine the slope between the points. If any of the slopes are different, then it is considered nonlinear. Now, to show that something is linear, you got to do the slope between all the points. So it's much easier to show something is nonlinear than it is to show that something is linear. And recall, we can calculate the slope from y2 minus y1 over x2 minus x1. So let's look at a couple of examples. Determine if the relation is linear. And again, this is the independent variable first. And the dependent variable second, regardless of the variables. Okay, so M1. We're going to look at the slope between these two. So M1 equals, you can subtract whichever way you want. The negative signs will work itself out. So I'm going to take this, subtract this. So negative 5 minus negative 7 over 2 minus 1. And this is 2 over 1. So the slope is 2. Okay, M2. I'm going to compare these two. M2. And the slope calculation is negative 5 minus negative 1 over 2 minus 4. So this is negative 5 plus 1. So this is negative 4. And 2 minus 4 is negative 2. And this works out to be a slope of 2 as well. So we keep going. We have to do the slopes of all points. So we're just missing this point. And we'll do this as M3. M3, we have 3 minus negative 1 over 7 minus 4. This is now 3 plus 1, so that's 4. And 7 minus 4 is 3. And it does not match the other slopes. So we say not linear. Okay, let's look at one more example. We'll do this one as M1. We have 9 minus 12 over 0 minus negative 1. This is negative 3. This is 0 plus 1, so it's 1. So we have a slope of negative 3. M2. We're going to look at this as M2. So we have 0 minus 9 and 3 minus 0. This is negative 9 over 3, and we have negative 3 again. So we continue on to check the last one, and we can check these two, M3. And we have negative 6 minus 0 over 5 minus 3. This is negative 6 over 2, and that's negative 3. We can say all slopes are the same, so it is linear. And another way you can do this is you can plot all these points and see if they form a line. If they do, it's linear. If they don't form a line, then it's nonlinear. And that completes this lesson.